For Chapter 7, Section 11, Exercise number 5, we are asked to find the solution to this sum that I'm actually going to reduce immediately. So I can rewrite as the sum from n equals to 1 and then 3 and 5 purely of 1 over n squared. Okay. Using the solution of our exercise 9.9. Alright, so as you can see, I have no a naught. Actually, I have no a. This thing is all a b n. So bn is actually equals to what? Well, we're gonna have 4 over pi, it's the constant in front, times the sum from n equals to 1, 3, 5 to infinity of 1 over n sine of n pi x over L. So if I do bn squared, I get 16 over pi squared. I ignore the sum, 1 over n squared, and I ignore the sine squared. So I can rewrite this better as 16 over pi squared over n squared. Perfect. So now we're going to have to find the f of x squared, but this is a piecewise function. So how do we do it? Well, let's try to rewrite it as f of x squared equals to, let's hit the first function. We're going to have integral from 0, actually no, from negative L is to 0, right? Yes, of negative 1. And this negative 1 should be squared, so squared dx, of course, then equals to 0 to negative L. So we're trying to take this negative L to be equals to 1. So if we assume that L is equals to 1, L is equals to 1, doesn't matter what you choose, it's always going to be simplified in the end. We're going to get 0 to 1, so we're going to have that the solution is actually going to be equals to x from negative 1 to 0, so negative 1. Actually, sorry, positive 1. And then the other piecewise function will be equals to almost the same thing, just from 0 to 1, because remember the upper L, we said L is equals to 1. So we're going to have 1 squared dx, and of course we're going to get x from 0 to 1, which is equals to x. Okay, now I'm adding these two together, but of course I have to find the average of these two. So I'm going to do the, right, 1. So I'm actually going to have the first one plus the second one divided by 2. So we're going to have 2 divided by 2, which is equals to 1. Perfect. So it will just get equals to 1. So now we have to have 1 is equals to our b, actually, sorry, 1/2 said addition from n equals to 1, 3, 5 to infinity of our bn squared. Like this, so it's easier if we do that. See? Bn squared is equals to this value over here. I have it pasted over here. Well, 16 n and pi over 2, and these two are all constants, so I can do 2, multiply both sides by 2, divided both sides by 16, multiply both sides by pi over 2 is equals to the sum, n is equals, actually I don't like this sign, n is equals to 1, 3, 5 to infinity of 1 over n squared. And as you can see, this value over here is exactly what we were asked to find at the very beginning. So our final answer will be equals to, well, let's solve it a little bit, pi to the power 2 over 8 is equals to the sum n equals 1, 3, 5, infinite value of 1 over n squared. And that is our final answer. you can see, it was pretty easy, pretty straightforward, as long as you know what to do. One thing you can do is actually you can change these values to be, for example, 2. Let's see what happens. So I'm going to change it everywhere. 2, 2, 2. But one thing now is that now this it's going to be, of course, in front it's going to be 1 over L. And now that L is 2, then we're going to divide everything by 2. So now we're going to get 1 over 2 of this, which will be, 1 over 2 of 2, which is equals to 1. And so as you can see, we just go back to the beginning. So it doesn't matter which choose L to be, as long as you keep it constant on both sides. So here will be 1 plus 1 divided by 2, which is equal to 2 equals 1. And as you can see at the end, we always get the same answer. Hope this is clear.